Hi everyone. In this video, I'm just going to go through building a modified version of Model 5-4. This is the inventory system model. It's specifically an EOQ model with stochastic demand. EOQ is economic order quantity. And so unlike the previous models we've built, this is not a queuing problem. This is an inventory control problem. So let's just go ahead and get started. From the lab handout, we see that customers arrive with inter-arrival times that are exponentially distributed with a mean of 0.1 days. So we say customers arrive. These are customers. They arrive at a mean of 0.1 days. And then also we are told that the first customer does not arrive at time 0. The first customer is also arrives randomly according to the same distribution. So we can just mirror the same distribution here, expo 0.1, okay? And then each customer places their order of 1, 2, 3, or 4 widgets with certain probability. So we can go ahead and create an assign module. There are other ways to assign this demand, but we're just going to use the simplest way, the way that we already know how to do. So demand, this is an attribute. Let's call this demand. And so our new value, I'm just going to type out the function. It's a discrete probability function. And so when we're inputting a discrete function into Arena, we're going to use the cumulative probabilities. So with 0.167, we're going to have a value of 1. Then cumulatively with 0.5, we'll have a value of 2. With 0.833, we have a value of 3. And then cumulatively, probability 1, we have a value of 4. So what this will do, it will assign one of these 4 values, 1, 2, 3, or 4 with these probabilities. Okay. I'm just going to pause the video and go close the door so the dog's barking isn't very loud. Sorry about that. So we have, where was I? Customers place their orders, and then the orders get logged and sent to an inventory control system, like a computer system. So what we're going to do is we have the physical customers coming, and we can actually put a little picture on this. We have the physical customers coming. These are people, picture person. But we have not only the person, the physical person, but we also have a separate entity that gets created, and that's the order in the actual system. So what we're going to do is we're going to clone this entity, and we're going to say whenever a customer comes in and places an order, the physical customer stays in this stream, but the customer order, one clone is created, the customer order is created and is sent to the inventory system. So we'll just say order is logged. In system, okay. And so now we have, once the order gets logged, the customers continue. If the demand can be met in full, given the current inventory level, then the customer is satisfied and leaves. But if there is no on-hand inventory, the customers have to wait until the stock is replenished and their orders can be fulfilled. So we're just going to use a new type of module. It's called a hold, right here. And so a hold is basically a wait until. So we're waiting until something happens. We're going to say wait for fulfillment. How do you spell fulfillment? I think that's correct. And then we're going to say that this is a scan for condition. So when a certain condition is met, then customers are going to pass through this hold. And if this condition is not met, then they're going to wait here until it is met. So the condition that we are going to scan for is, actually we can just type it out directly. We're going to wait until demand, keep in mind this is an attribute that belongs to each entity. Demand must be greater or equal to the current inventory level. So if inventory, sorry, other way around. If inventory ever drops below demand, that is, if demand cannot be fulfilled, then customers will just start waiting here until this condition is met, the inventory is increased, we buy more stock, and the demand can be fulfilled. So we're going to hit OK. And then once they've been fulfilled, they will leave the system. So we'll go back to our dispose, customers leave. Okay. Now, with every time an order is logged, right, we had here that the order is logged. This is, we're going to say this is a label. So this is now just somewhere else in the system. So now Arena will say that when this entity, the customer, gets cloned, we will send the clone here to the label order is logged in system. So when the order is logged in system, we will update our inventory levels. Let's call this subtract from inventory. And we're going to say that the variable that we're going to call inventory is going to be equal to the previous inventory minus demand. Okay, so anytime an order comes through, the inventory is going to be subtracted by that amount, and then the order is going to be discarded. So we're going to say the order is processed. So now we have, this is the order side of the inventory system. This is where the inventory gets depleted. Now we need to consider the restocking, the replenishment side of the inventory system. So we're told that at the start of each day, Bucky, the owner of this warehouse, comes in and takes inventory to decide whether to place the order with the widget supplier or to leave it for the next day. So we're going to be using just the basic EOQ model, and this is where we have a maximum inventory level and a minimum inventory level. So when the inventory depletes to a certain level, certain point, our minimum threshold, we'll call this variable little s, then Bucky will place an order and it will be replenished up to the maximum inventory level. So let's model that. We have Bucky evaluates. So this is Bucky who walks in, and he comes in at the start of each day. So every day he comes in at time 0, and then he comes in at the beginning of the next day, and the next day, and the next day. And he comes in and he decides, am I going to place an order? If Bucky decides not to place an order, then we can say that no order is placed, and this replenishment side of the system is finished for the day. So let's say no order is placed. Okay. And so how do we decide to place this order? We're going to use the two-way by condition, and we're going to say, do we place an order? And we're going to place the order if the variable called inventory is less than or equal to some minimum value. We'll call this little s. Or we'll call this little s. Okay. And then if an order is placed, Bucky needs to determine how much to order. So we're going to put in a sign here, and we're going to say assign orders. Okay, determine order size and costs. Okay, and so we're going to create an attribute called order size. And this is going to be equal to our maximum inventory level. So this is our big S minus our current inventory level. Okay. And then there's going to be a lead time between half a day to a day. So we're just going to put in a delay and call this lead time. And this is going to be, again, half a day to a day. Okay, let's connect these. And then once the order is delivered, we're going to update the inventory level. And we're going to say that the variable called inventory is going to be the previous inventory level plus the order size. Okay. And then once it's been delivered, then we just exit this part of the system. So we say order has been received. Now we can see what we have now all of the inventory levels being updated, but now we need to attach the associated costs. So anytime an order is placed, we have a cost, and we'll call this, we'll create a variable called total order cost. And this is going to be equal to the previous total order cost plus a flat fee of $32 plus $3 times the order size. So for every order that's placed, we have a one-time processing fee of $32, and then it's $3 per part. So we have OK. We can hit OK. And this is now our full inventory system. Now, the things that Bucky wants to measure are the average operating cost per day. So the average total operating cost per day of this system. So we're going to go and create some statistics. We have our average order cost. And this is going to be calculated at the end of our simulation. So this is an output variable. And this is going to be equal to the total order cost that we're keeping track of divided by the current time and system. Now, it will try to calculate this at the beginning, and at the beginning of our system, t now is equal to 0, so we'll get an error message if we just put this in. We'll say try to divide by 0. We can't do that. So we're just going to add a very, very, very small amount just so that doesn't happen. Okay. We're going to keep track of the holding cost. And so now holding cost are the amount of money it costs to store one item of inventory for 1 unit of time. And we are told that that is equal to $1 per unit unit of time. And so this is something that's constantly changing as the inventory level changes. So this is a time persistent statistic. And this expression is going to be equal to the maximum between the inventory level and 0, because we are only have a holding cost when inventory is positive, times $1. So this will take our inventory level, if it's positive, or 0, and multiply that by 1. And so that's going to be our holding cost at every point in time in this model. And we can do the same thing now. We have a shortage cost. So this again is a time persistent statistic. And this is now when the inventory becomes negative. So we can say this is the maximum between negative inventory and 0. And the shortage cost is $5. And then the statistic that we are interested in is the average operating cost of this system. And so this is something that's going to be calculated only at the end of running the model. So this is going to be an output statistic. And we can go to build expression. And we're going to look at our statistics. We're going to look at the output of our average order cost plus the average value of our holding cost plus the average value of our shortage cost. And this is now our average operating cost for the system. Okay. And now we're going to run this model for 120 days. And we can look at our base time units in days. Everything is given to us in days. Now, even though we want to look at it for 120 days, we don't want Bucky to come in at the very last minute and place an order that will not have a chance to be fulfilled by the time the simulation ends. So instead of 120, we're actually going to cheat a little bit again and put 119.9999. Okay. And now, while the simulation is running, Bucky wants to see certain statistics being tracked. So we can actually do a couple things. This is our main model, so I'm just going to zoom in on this model. And I'm going to go to View, Named Views, and I'm going to create a view, Add, and I'm going to call this M for Model. Okay. So now what this will do is anytime if I've scrolled away from it, if I press the letter M, I'm pressing the letter M on my keyboard, it will jump back to this view. Bucky also wants to see some metrics being tracked. So let's move over. Bucky wants to see metrics for the average daily order cost, so the order cost, we're going to look at the average value of the order cost. Okay. and we can call this average order cost. We also want to look at the average holding cost we want to look at the average shortage cost, and the average total cost, total operating cost. Okay. In addition to seeing these numbers being tracked in real time, Bucky also wants to see a plot of the inventory level at all times. So let's create a plot. We're going to add a series, and we're going to call this positive inventory. And the expression is going to be the maximum between inventory and 0. And we can make this color in green. Okay. We can add a second series. We can call this negative inventory. And this expression is going to be the minimum between inventory and 0. So this will be the plot when it goes negative. So we'll put this line in red. Okay. And then we can go through and format a few other things. I'm going to come in and I'm going to say that I would like my legend on the bottom. It just takes up less space that way, so I can see my graph more clearly. I feel like this background is a little dark, so I'm just going to make the back wall a little bit lighter. I'm also going to come here and say that when I scroll from the bottom, I don't want to scroll fully. I'm just going to scroll halfway at a time. And so if we have 120 days and we're looking at everything in days, let's look at this 30 days at a time. Okay. Okay. And then the final thing we want to do is we want to go and make sure that we set our initial values for our variables. So we have our inventory level. Let's say that initially our inventory is 60. And then we can set our big S. And this is going to be, let's see, reorder up to 40 is our maximum inventory. And then we can have our little s. Let's say we reorder when the stock goes down to 20. We can go ahead and hit play. And we can see that this inventory so if you're familiar with this type of a model, you're used to seeing just a very regular sawtooth, but since this model has both stochastic demand and stochastic lead time, these peaks and valleys are also a little bit random. So we can look at that. And then we can see that our average order cost is $25, our average holding cost is $10, average shortage cost $18 per day. So our average total operating cost is $52 per day. that's pretty high. We can see if we can tweak some things around and reduce this. So let's try now, instead of ordering up to 40, let's order up to 60. That's our original inventory level. And we can keep our, we can change our reorder quantity to, let's say, 30. Okay. And we can run this again. So it looks like it's going negative far less. Let's see if we can just speed things up a little bit. And we see now here our average total operating cost is $44, so that's pretty significant reduction. And you can continue to play around with these initial values for these variable levels to see if we can find an average total operating cost that is minimized. In a later lab, we will learn how to do this more systematically, but for now we can just open these up and play around with it a little bit. Anyway, I hope you found this video helpful, and I will see you guys all, press the letter M, later. Bye.